take it all the way to the top.
All the way to the top. Shows you how I know what I'm doing, right?
Okay, that's far enough.
Alright. So, do you want to pour yours, or I can pour it?
Why don't you hold the water?
Yeah.
That's combustible.
Yes. You broke her concentration.
Oh, sorry.
That's why we have paper towels and lots of. Alrighty. Now we are going to take food color, and you can pick your color. What color do you want? We have the 3 colors you saw in there and green. You're gonna do red? Okay. I don't want you to get dye on your hands. Even though I didn't touch it, I still got dye on my hands, so I don't know.
Safety first.
And that, if it ever gets down in water, will dissolve. It's a pretty cool effect. It's delayed. I need to go with blue. And we need to wait for the bubbles to
Why don't you
separate.
just talk about whatever you're trying to explain? Go ahead and talk about the phenomenon.
Okay, so the reason that these haven't dissolved yet, and it took so long for them to get down there to dissolve, is because water and oil, they don't mix. And it's because water is a polar molecule, and that just basically all it means is it's not going to mix something with something like oil, which is a non-polar molecule, and that if you looked at a picture like a diagram, the water would be unbalanced. It would have more electrons, which are negative, on one side than and positives on the other, and it wouldn't be balanced, which is called polar, like a magnet is. Where it has the positive side and the negative side. The same kind of thing goes on here, and that's why water doesn't mix. And the dye is water soluble, but it's not oil soluble. So that's why it didn't color the oil and not the water, because it's only going to color one or the other. But as far as that goes, we have Alka-Seltzer, well, off-brand, but Alka-Seltzer. And do you know how these work? Have you ever had these when you were sick? Okay. The way it works is when you put it in the water, it fizzes. And it's going to create little bubbles that will, in the water, I don't know if that's going to fit, so I may have to break that. So you can break yours in half, and then we'll drop them in at the same time. Okay. And what it's going to do is, when it shouldn't fizz until it gets down to the water, and then it'll react with the water and fizz, and it creates bubbles. And once they get to the top, the bubbles pop, and the water comes back down to the color.
So there's a little lava lamp.
And you can, we can hear it because we're over here, we're close, but we can hear the bubbles popping, we can hear the fizzing. And it's just a chemical reaction that releases gas down at the bottom. And when, like I said, when the gas gets up to the top, the gas is released into the air, and the water, which is less dense, or denser than the oil, goes back down to the bottom. And that's why you have the continuous cycle. And we could do that as many times as you want, but that's how that works. Or you can screw the cap on, and we can send you home with some of these, or if you have them some at home, you can do it again when you get home. But that's the...
Important point, not to put the cap on until
Yes.
the fizzing stops.
You don't want to put the cap on before it stops, because if you do, it's going to create pressure because of the gas that's released, and it would expand and expand and expand, and eventually, if there was enough pressure, it would explode and go everywhere.
Depending on how tightly you get the freeze down.
Theoretically, it would explode.
Okay.
So that's that. Do you want to do it again, or we can move on to the next thing on the list? Okay. So now that we've seen that they're done, we can put our caps on so that we won't make a mess if we knock one of them over. And
Just set 'em over there.
we can set them back here.
So what you want to do is just take the pencil, and you don't have to go fast, you don't have to go slow, just kind of slide it through and go through to the other side. Just stop when you get through the other side though. So just go ahead and stick it through and keep going. Uh-huh.
What would happen if we put another pencil?
And you can put another one in there if you want to. You want to do more than that? I have several. Just don't get too close together. Too close together. No, and don't push on it. You might stretch. So why does this happen?
I have no idea.
Why would you want to do this? That's the I have no idea question, right? So, did you know you were magic?
No, I had no idea it was magic.
Okay, you were magic. So, anything special that we did?
No.
So, is it a magical plastic bag?
No.
No? So, how does it work? Any ideas?
I have no idea. Do you want to?
Macy, do you have an idea? Have you ever done this before?
No.
Okay. Now, you are not allowed to go home and put pencils in all of the plastic bags in the kitchen. Okay, just remember that. Okay, what do you think, Ashton?
Well, if you look really close at the edge of the pencils, you can see that the plastic is against the pencil, so it's creating a seal. And as long as you don't pull the pencil back through, then you're going to keep that seal and the water won't come out.
That is correct. So plastic is made with polymers, and polymers stretch. They have stretch to them, so whenever we put the pencil through, that stretch the polymer, so it's sealed around the pencil. So do we think it will leak if we take the pencil out?
Yes.
Okay, so I'm going to do mine. Ready? Are you watching? No, we're good. Ready?
You better a little lower.
Yes. You think I can put it back there and stop it?
Maybe. Depends on how well you can get it back through the hole.
Yes.
Very nice.
Okay, very good.